now move on to the next speaker, which is Dr.Junbo from Aker Solutions. He works as an engineer there. He's an expert in the analysis and design of offshore and onshore wind farms, and also structural wind engineering and design of marine structures. So he's an elected member of the Norwegian Academy of Technological Sciences, and he serves on the editorial board of 5 scientific journals. He is also a sole author of several comprehensive scientific monographs, all on expert areas of engineering. So he will speak to us about offshore oil and gas, from offshore oil and gas to offshore wind farms. So thank you and welcome. Please go ahead.
Thank you so much. Can you see my screen now? It's
yes. Yeah.
Full screen, right? Yeah. It's a pleasure to attend this seminar on sustainable energy, and I have listened to very interesting topics about this security, energy security in Sri Lanka, and also this.
Sorry, Dr. Jed, I think we're seeing it as a split screen, so you've got the next slide. Do you want to have it as a full screen?
Okay, I see. Yeah.
Are you happy with that? Or?
Yeah, I see. How I can do that? Yeah.
Yeah. Okay.
Yeah. So yeah. You can see that now, right?
Yeah, that's fantastic. Yeah.
Yes. Yeah. Yeah. It's very two interesting topics, and I will be more focused on a part of the renewable energy in the offshore wind. So my topics will be from offshore oil and gas to wind, industrializing the offshore wind. So first, I come from Aker, and we have a product history of almost 180 years, and we deliver solutions from the subsea to the surface, as you can see in this picture, including some subsea equipments, and also all the way top to the sea surface, like different type of marine structures. And throughout our history of 180 years, we have 2 backbones. One is marine and the other is mechanical. And we can survive in such a long history because we try to optimize and adapting to some new environments. And now we see that offshore wind is a future trend. So our vision is to be a leader in forging a sustainable future for the global energy industry and the world. So we have currently more than 13,000 plus employees located in more than 20 countries in 51 locations worldwide. So why offshore energy? Because compared to the land-based wind energy production, there are several obvious advantages, and also there are some disadvantages as well. So I just list some of the advantages. Like in offshore, the wind is much stronger than onshore. As you can see in this picture, just 10 kilometers from the shore, at the height of 250 meters above the sea surface, you can have the same wind speed as 400 meters in the suburb. So which means you get the same energy regarding the height of your wind turbine tower. You can decrease by 150 meters. And also around 80% of population is located within 200 kilometers from the shore. So which means the majority of population can benefit from using the offshore wind power, because a significant part of the wind power is a great cost. And if we can close to the source, we can save a lot of this electricity transmission fee. And also offshore have a lot of space to expand. And also they have lower environmental impact, like what the the second colleague or the speaker talking about those environmental like noise, I listened. The noise offshore isn't a problem, at least for the people. Maybe it can have some potential thing to the mammals and other animals, but for the human being, that's not a concern. And this shows the trend of investment of offshore oil and gas and offshore wind. As you can see, until this year, the offshore oil and gas upstream began to go down, which is even will be lower than the offshore wind investment. So that's one of the main issues that Aker is facing, that we are going to spend more effort on the offshore wind part. So the offshore wind farm industry actually involved different stakeholders like the substructure manufacturer and designers, turbine manufacturer and component suppliers, blade designers, like we have several big ones in Europe, like Vestas and Siemens. Also the park owners and operators. Insurance company can be a very important part for developing the offshore wind business also. So consultancies, big or small, and installation is a very significant part with regard to the engineering for offshore wind development, also academia, because there are actually Norwegian academia is one of the first in the world to be heavily involved in the development of offshore wind. So they have contributed enormously about the new knowledge for this part of the business. So the offshore wind in Europe, because I'm a structure and geotechnical engineer, I'm talking about the foundations. The majority of foundations in Europe or in the world so far is the so-called monopile, which means a single pile foundation penetrated into the soil and further up to connect to the wind tower. The tower can be 100 or 200 meters high. This hold this wind turbine. And now we see the trend that there are more and more jacket type of structure, as you can see here, because as I will talk later on, there is a strong demand to have a large wind turbine because offshore wind farm need to have as less number as much regarding the foundations. So we have to reduce the foundation number, but increasing the power generation of each wind turbine. That's why we have to use more stronger jacket structure rather than the monopile. And also jacket structure are adaptable to different type of soil environment, soil conditions compared to the monopile. In Europe, monopile may be okay because the majority of the seabed soil condition is very good sand. But if you go around to Asia, especially in the South and the East Asia, there can be a very difficult geotechnical conditions like very deep mud. So you have to use other type of foundation type. Jacket is a very good target for that. So there are also some other type of structure like the tripod, but because of this redundancy is not that good, so their application is limited. Yeah. So from the onshore wind to offshore wind, it's actually a synergy of land-based wind turbine business and offshore engineering together. But there are certainly differences between each of them, and also there are some new knowledges. Like for offshore oil and gas business here, we normally develop a single offshore platform. It's like tailor-made. But for offshore wind, we have to actually develop maybe 5 to 10 or even 100 turbine. It's not tailor-made. It's sort of like mass production. And also, for example, the dynamic loading for the offshore engineering structure is less adverse than offshore wind because there are more dynamic loading here, and also especially regarding the fatigue, because under repeated loading, the material can break in a rather low strength compared to the material strength of steel. That's the reason, because that is this cyclic loading effects. So fatigue is a major concern. For the offshore wind, there may be 10 to 100 million cycles of fatigue loading during the surface life, compared to only 1 or 10 million cycles of fatigue life for normal offshore oil and gas structure. That will be significant fatigue problem involved. Regarding the dynamics, as you can see, for example, this is like energy spectrum of the wave loading. And you will see for many fixed bottom offshore structures, they are located in the left side, which means they try to be very stiff to avoid resonance. And for many flexible floating structure, they are in the right-hand side. The major concern is to avoid this resonance with wave loading. But we also have the very very high occurrence of fatigue wave, which means very small amplitude of waves, which can cause we call that semi-resonance of the offshore structure. And that's why one important part of offshore engineering is to work on to mitigate the fatigue damage for different type of structure and foundations. And also we have wind loading. This is actually low frequency or high period loading, which can also trigger resonance problem, different resonance problem for the floating structures. That's actually a lot of concern for offshore structure, not only to the offshore wind substructure, but also for the offshore oil and gas structures. So the dynamics plays an essential part for offshore engineering, especially for the structure and foundations. And also different from the offshore engineering, offshore wind loading, from loading point of view of those wind developer knows it's not necessary that the maximal loading occurs at the maximal wind speed, because at the rated service wind speed, for example, around 12 meters per second, because it will optimize the wind turbine with some pitch control to generate the largest electricity output. The dynamic thrust force can be even bigger than extreme wind loads in many cases. So this means that operational conditions may have a considerable contribution to extreme response and also the fatigue damage, as I have mentioned, and they need a more dedicated consideration of wind and wave load and how to combine them. That's make a very different situation compared to the normal offshore oil and gas. And this is one picture I took.
Sorry, Dr. Jia, you got about 2 minutes.
Okay, yeah. So it's a high wind sampling I took in June 2017 when I went to another of floating structure in the shipyard in Stud, just nearby Bergen. And I show this picture because I want to mention the installation part, as I talked about previously. This Saipan 7000 means each crane can carry 7,000 tons weight at around 42-meter height. This means that for offshore wind development, we need enormous high capacity for installation. I try to keep that shortened. Aker Solution have more than 40 years of experience on floating structure design. That's one of our actually focus to develop offshore floating wind. Like we have developed so far the largest drilling floating platform, Aker H6E, and also the world's largest FPSO. in Australia, and the largest sparse floating structure called Asta in North Sea. And our focus now is try to commercialize some of our concept of floating wind, and we are actually at between the pre-commercial to commercial stage for different projects in the world, both in Asia and also in North America and Europe. And this is one of our aligned partner principal power that developed this wind float is very famous because they have several important things, especially this active ballast system that allow you to put your wind tower and turbine in one of the columns rather than in the middle. That saves a few hundred tons of steel. And we also provide services for the cable. And we have so far delivered more than 5,000 kilometers of steel umbilicals in the world, which dominate around 30% of the global market. And this is some of our projects in Norway, in Africa, in Australia, in US, and also we have developed that to Asia, mainly in China. And now we are involved in the power to platform development. One of the things maybe you have heard is high wind with 11 wind turbines installed at total 88 megawatt to provide electricity to the offshore oil and gas platform at North Sea for Equinor. That's we have involved. And also this shows some of our refined analysis for one we call the vortex-induced vibrations. We use a very dedicated CFD software to simulate that. Without those efforts, you can never reach a success in development of offshore wind and offshore engineering business. Yeah. So the strategy to cut the cost for offshore wind development, we have technology part and research. We have supply chain. We need the mass production to commercialize, and also the government policy support is very important because time limit. I don't have time to develop to further talk about that. So thank you so much for the invitation to attend this sustainable energy seminar, and look forward to have any of your questions through the chat box. Yeah, thank you.
Thank you very much, Dr. Shia. That is very interesting to hear about the offshore, because I guess at the moment in Sri Lanka we only have onshore, but obviously, as you mentioned, it's actually probably less environmentally, probably more environmentally friendly. So
yeah, it's a quite long coastline in Sri Lanka, so it's a potential future there. Thank you.
Thank you very much. So now we sort of a slight change. We're